This is an induction proof using divisibility. So this is a nice, relatively easy one to start with. So 3 to the power of n plus 1 can be divided by 2. All integer values, n is greater than 0. So how we're going to prove this using induction, we start off by making n equal to 0, because that's the first number here. And we put 3 to the power of 0, which gives me 1, add 1, and that divides by 2. Now the next line, quite important how I set this up. N equals k is true. So 3 to the power of k plus 1. That divides by 2. So that gives me a multiple of 2. So it could give me 2 times something. And that's going to be used later. Let n equal k plus 1. Now this is my inductive part. So I'm now just going to put it in. 3 to the power of k plus 1 plus 1. And I'm just going to think about rewriting that. So I can write that as 3k plus 1. Now, I would love to get this part here. If I had this part, something with this part here, I could replace it with 2a. Well, I've got the 3k, I've got the 1, but I've got 3 lots of 3k. Well, if I was to make this 3 to the power of k, add another 3k on the back. So it's just taking 3 of those and putting one of them here at the back. Now that part there, I know divide by 2. But it also leaves me with, instead of 3 times 3 to the k, it leaves me with 2 times 2 to the k, which is very handy. So this gets replaced with 2a. There's a 2 in both parts of that. So if I factorize it, I now know that I have an even number. And so the proof holds for n equals k plus 1. It holds for all values of n.